Welcome back to the Living Soil Lab. The gardening world is full of passionate debates, but few questions spark more curiosity than this: what really works best for building soil and feeding plants? Today we're settling one of those debates with hard evidence from a controlled experiment that might completely change how you approach soil amendments. We took potato water, that humble kitchen byproduct, and pit it against compost tea, the beloved gold standard of organic gardening. The results surprised even us, and they're about to give you a completely new perspective on what your soil actually needs to thrive. Designing a fair fight. Any experiment is only as good as its setup, so we eliminated every variable we could to ensure these two amendments got a truly fair comparison. We started with 12 identical plants, 6 tomato seedlings at the exact same growth stage, all propagated from the same parent plant, to ensure genetic consistency. Each seedling was transplanted into identical 5-gallon containers filled with the same batch of average garden soil. Nothing special, just the kind of moderately fertile soil most gardeners work with. We deliberately chose soil that wasn't depleted, but wasn't particularly rich, either, giving both amendments room to demonstrate their effects. The containers were arranged in a single row where every plant received identical sunlight exposure throughout the day. We watered all plants on the same schedule using measured amounts, keeping moisture levels consistent across the board. 3 plants received only plain water as our control group, 3 received potato water applications, and 3 received compost tea treatments. Every other factor, temperature, humidity, air circulation, remained constant for all plants. This level of control meant that any differences we observed could be attributed specifically to the soil amendments themselves, not to environmental variations or luck. For the potato water, we used the simple fermentation method you're probably already familiar with. We collected water from boiling unsalted potatoes, let it cool completely, then allowed it to ferment in covered jars at room temperature for 7 days. The resulting liquid had that characteristic slightly sour smell and cloudy appearance, indicating active microbial fermentation. We diluted it at a ratio of 1 part potato water to 10 parts fresh water before application, pouring it directly into the soil around each plant's root zone every 2 weeks. The compost tea required more effort, but followed traditional brewing methods. We filled a 5-gallon bucket with dechlorinated water, added 2 cups of high-quality finished compost wrapped in cheesecloth, and a tablespoon of unsulfured molasses to feed the microbes. An aquarium air pump bubbled oxygen through the mixture continuously for 24 hours, creating an aerobic environment where beneficial bacteria and fungi could multiply exponentially. After brewing, we strained out the solids and applied the tea at the same frequency and volume as the potato water, every 2 weeks, thoroughly soaking the root zone. Watching the transformation unfold within the first week after initial applications, subtle differences began emerging that only grew more pronounced as the experiment progressed. The compost tea plants showed the first visible response. Their leaves took on a slightly deeper green color within just 3 days, suggesting improved nitrogen uptake. The potato water plants showed less immediate change, maintaining a color closer to the control group for the first 10 days. This early lead for compost tea matched our expectations, given its reputation for delivering quick results. By week 3, the story became more interesting. The compost tea plants had developed noticeably thicker stems and larger leaf surface area compared to the controls. They looked vigorous and healthy, exactly what you'd expect from plants receiving regular microbial inoculations. But the potato water plants had started their own transformation, not in size or leaf color particularly, but in something harder to quantify. Their leaves had a certain resilience and structure, standing firm rather than drooping in the afternoon heat like the control plants did. When we gently stressed all plants by skipping 1 watering cycle, the potato water group recovered fastest, suggesting improved drought tolerance. At the 6-week mark, we carefully excavated 1 plant from each group to examine root development without disturbing the others. This underground investigation revealed fascinating differences. The control plant had a standard root system, adequate but unremarkable. The compost tea plant showed impressive root mass with many fine feeder roots, exactly what you'd expect from the boost in soil biology. The potato water plant surprised us with something different. Its roots were slightly less abundant than the compost tea plant, but they were notably thicker and more robust, with visible mycorrhizal associations on the root hairs. The potato water seemed to be encouraging different types of soil organisms, particularly fungi, which formed beneficial partnerships with the plant roots. The final verdict and what it means. After 12 weeks we measured and weighed everything: plant height, stem diameter, leaf count, total biomass, and most importantly, for tomatoes, fruit production. The compost tea plants averaged 23% more total plant mass than the controls and produced their first ripe tomatoes about a week earlier. These results confirmed compost tea's reputation as a powerful plant booster. The numbers were impressive and would justify the time and effort required to brew it regularly. But here's where it got interesting. The potato water plants averaged 18% more total plant mass than controls, not quite matching compost tea, but still a substantial improvement from something that costs absolutely nothing and requires minimal effort. Where potato water really shined was in fruit quality and plant resilience. While the compost tea plants produced slightly more tomatoes overall, the potato water tomatoes were noticeably firmer with thicker walls and deeper flavor in our taste tests. The potato water plants also showed superior resistance to common stresses throughout the experiment. They handled heat better, bounced back from underwatering faster, and showed less leaf damage from minor pest pressure. The soil itself told an equally compelling story. We sent samples from each group for basic analysis at the end of the experiment. The compost tea soil showed elevated bacterial populations and increased nitrogen availability, explaining the quick greening and rapid growth we observed. The potato water soil had different characteristics: higher fungal populations, improved soil structure with better aggregation, and increased potassium levels. The fungi encouraged by potato water create stable soil structure and help plants access nutrients more efficiently over time, even if the immediate growth boost is less dramatic. Putting knowledge into practice. So which amendment wins? The honest answer is that it depends on what you're optimizing for and what resources you have available. If you want fast growth, lush foliage, and maximum production in the shortest time possible, compost tea delivers undeniable results. It's particularly valuable when starting new beds, feeding heavy feeders during peak production, or rescuing struggling plants that need intensive care. The downside is that brewing proper compost tea requires quality compost, equipment for aeration, and consistent attention to timing and brewing conditions. If you do it wrong, you might actually brew harmful anaerobic bacteria instead of those beneficial microbes you're aiming for. Potato water offers a different value proposition: modest but consistent results, and, honestly, with virtually zero cost or effort. You're using something you'd throw away anyway, turning waste into a resource, and you don't need to buy any supplies or spend much time on preparation beyond just simple fermentation. The resilience and stress tolerance benefits we observed really suggest that potato water builds long-term soil health, rather than just giving you those quick nutrient hits. For container gardens, balcony gardeners, or, anyone without space for compost tea brewing setups, potato water is remarkably effective for the effort required. Here's the exciting part: these amendments aren't mutually exclusive. Several gardeners in our community have experimented with using both in alternating applications, or even combining them. The microbial diversity from compost tea paired with the fungal encouragement and potassium boost from potato water might create synergistic effects that exceed either amendment alone. We're currently testing this combination in a follow-up experiment, and, early results look promising. The real lesson from this test goes beyond just choosing between these two options. It's about understanding that, honestly, soil health isn't one-dimensional. Different amendments support different aspects of the soil ecosystem, and the best choice really depends on your specific plants, soil conditions, and goals. You know, the most successful gardens aren't built on a single magic solution. They're built on diverse approaches that work together to create resilient, living soil capable of supporting abundant life. Hey, why not try this experiment yourself with whatever plants you're growing? And, document your observations and share the results. Gardening knowledge really grows when we all contribute our experiences. Go ahead and subscribe to the Living Soil Lab for more evidence-based gardening experiments that cut through the myths and give you real, actionable information for building better soil and growing better food. Together, we're not just growing plants, we're growing a community of curious, thoughtful gardeners who question, test, and share what actually works.